Dear students, today we are going to discuss about introduction to Pandas data structures using Python. So Pandas is a popular Python library for data manipulation and analysis. It provides two primary data structures which we are going to discuss today. The first one being DataFrame and the second one being the series. These data structures are designed to handle structured data, making it easier to work with data sets in a tabular format. First, we will discuss about the data frame. So a data frame is a two-dimensional labeled data structure that resembles a spreadsheet or an SQL table. It consists of rows and columns where each column can have a different data type, like integers, floats, strings, or even some custom data types. You can think of a data frame as a collection of series objects where each series is a column. Data frames are highly versatile and are used for a wide range of data analysis tasks, including data cleaning, exploration, and transformation. Now we will study about a few ways of creating a data frame using pandas. First method is creating a data frame from a dictionary. So as you can see, there is a code for this. We are importing pandas, obviously, because we are using a pandas library here. We wrote import pandas as pd, where pd is just an alias, that is a renaming of the pandas library here. Next, we have taken a dictionary. As you can see here, we have taken a dictionary here. Okay, so the dictionary here is name colon Alice Bob Charlie. What is name here? So my dear students, here name is the key and Alice Bob Charlie together is a list. So name is the key, the list which we can see is the value. What is the next element of the dictionary? We have age as the key and 25, 30, 35 as the value, that is a list here. Similarly, look at the third key of the dictionary, that is city, and what is the value? The corresponding value is again a list which contains elements like New York, San Francisco, and Los Angeles. So to create a data frame by using this dictionary, we have to use an inbuilt function called DataFrame and pass our dictionary as the parameter. So what did we write? Why did we write PD here? PD, as I already said, is an alias for pandas. So we wrote PD dot the inbuilt function which is stored inside pandas. So we wrote pd dot data frame and we have passed data, that is the dictionary, as a parameter here. What is the output here? Output is df, which is just a variable here, and it has the resultant data frame now. So now if I print df, that is the data frame, our output looks like this. Students, please note one thing here. The first column which we see here contains the index values 0, 1 and 2, which is taken by default here. We have not placed this, right? So it is taken by default. And as you can see, all the key values of the dictionary have been taken as the column headings. And all the values, corresponding values of the dictionary, they have been taken as the column values. Going forward, we come to the second method of creating a data frame, which is from a list of lists. So we can see here, we have a list of lists here. What is the first list here? That is 1, Alice, 25. What is the second one? 2, Bob, 30. And the third one is Charlie, 35. Now, here there is a problem. Since we are making a data frame from a list of lists, we don't have a column heading here. So in case if you want a column heading, you should just add a small variable. Okay, so we will see in the next line. In the same way as the previous one, we wrote pd dot data frame, which is the inbuilt function. What is the parameter, or rather, what are the parameters which we are passing here? First, we have data, that is the list of lists which we defined here. Next parameter, my dear students, is columns. And inside columns, we wrote a list here. The list contains the column headings. So this is how you can provide column headings to the data frame if you are creating the data frame from a list of lists. So what are the first column, that is ID, has the values which has been taken as from the first element of all the lists here. Okay, and so on. Again, my dear students, please note that the first column, that is the index values, that is 0, 1, 2, has been taken by default. We have not put it. Now we come to the third way of creating a data frame by using a list of dictionaries. So in the first case, we had used one dictionary. Here we are using a list of dictionaries. What did we do here? As you can see, my dear students, there is a list. There are multiple dictionaries inside that. So for the first dictionary, we have name as the key, Alice as the value. What is the next element? Age as the key and 25 as the value. What is the third one? City as the key and New York as the value. My dear students, just note here, since we want a fixed column name for all the columns here, column headings here, right? So make sure to give the same name here as the key. So all the dictionaries have something in common. What is that? All the key values, right? So you can see name, name, name. We have just changed the value of that name for the dictionaries. So we have got a beautiful data frame here. Again, my dear students, note that the first column, that is the index values, is being put by default, like we have not put it. The fourth way to create a data frame is from using a NumPy array. So we all know that NumPy is another library of Python, and hence we have to import both Pandas and NumPy here. And this is the NumPy array. So my dear students, we have taken a NumPy array here. We have in a similar way created a data frame by using the data frame function. We have passed the variable data, that is a NumPy array. And what about columns? What about columns here? The columns here you see are the names of the columns A, B and C. So my dear students, since we are using an array, we did not have column headings. So we have used the columns variable too. Now for the fifth and sixth method, okay, we are taking a CSV file and an Excel file. So it's very easy. There is nothing much to explain here. This file.csv is the CSV file and file.xls, that is the Excel file. So directly we can take CSV file or XLS file as the source and create a data frame. Now we can write a code. You all can try it at home. You all can just take a CSV file. Okay, I wrote it as this program actually takes a CSV file and prints the first 5 rows and last 5 rows of it. Okay, so what are we doing here? We take like your file.csv. Here you can put your CSV files path. Okay, so we store it in a variable called file path. Now we are using an inbuilt function called read_csv, which we have studied in the previous slide here, and we are reading the the CSV file's path, right? And we have got our data frame. What did we do after that? We have just printed the first 5 lines by using an inbuilt function called head. Head will retrieve the first 5 rows. So by default, if you do not pass any parameter here, it retrieves the first 5 rows. If you want to change that, you can accordingly put a number here. So if you put 1, it will retrieve the first 1 row. Okay, so on and so forth. Now, what about this line? So it will print the last 5 lines. Please note one thing here, students. When it is printing the first 5 and last 5 lines, by default it is taking an extra line on the top, which is the column header of your original CSV file. We have also provided an explanation about the head and tail methods here. So the head and tail methods return a specified number of rows from the top and bottom respectively. Both the methods return the first or last 5 rows if a number is not specified, as I already said to you. Please note that the column names will also be returned in addition to the specified rows. If your CSV file has a header, the first row contains the column names, right? Pandas will treat that first row as the column header and not as a data. Next, we come to the second data structure, that is series. Now, a series is a one-dimensional labeled array that can hold data of any type. It is like a column in a data frame or a single variable in statistics. Series objects are commonly used for time series data as well as other one-dimensional data. Time series data consists of data points indexed in time order. A Pandas series is ideal for storing time series because it can handle timestamps as indices, which makes it very easy to align the data. For example, if we want the stock prices over time, the key characteristics of a Pandas series is its homogeneous data. But remember one thing, student, as I already mentioned in the slide, it handles this by converting everything to a common data type. We will see one example now. The second characteristics is that it has labeled data. So it has data itself and it has an associated index with it. The index, my students, provides labels or names for each data point in the series. By default, the series have a numerical index which is starting from 0. But you can specify custom labels. And the third feature is the size and shape. Series has a size, that is a number of elements which are present, and a shape because it's one-dimensional, but does not have columns or rows like a data frame. Now we come to creation of a series. The first method is from a list. So in the similar way, we import Pandas as PD here. Okay, this is a list containing some integer types. We make a series here by using the inbuilt function called series and passing the data, which is a list here, as the parameter. And then when we print series, we can find this output. So my dear students, as you can see, again the index column here, that is 0, 1, 2, 3, 4, was taken by default. And this D type, that is the data type, that is int64, was also taken by default by Python. We have not asked to print that. Okay, I wanted to show you another example here. So here you can see, if you want to custom the labels, as I already shown you, if you do not mention any labels here, okay, by default labels are put from 0. Okay, numeric labels 0, 1, 2, 3, 4, it is put like that. But suppose you want to custom the index value, that is the first column here, we can do that by using a second list. Yes, we have used a second list and we have named it as labels, and we have passed that value, okay, as the value of the parameter index. So now this function series has two parameters. First is the data, next is the index. Now you can see the index values are changed. So you can change it accordingly. You can name it as your own wish, according to your wish. I wanted to show you one more thing. Since I mentioned that it is homogeneous data here, what will happen if I put hello as the first element here? Will Python throw any error here? No, not really. It will by default, or it will, you can say it's an implicit conversion. So implicitly it will convert this hello along with all the other data what is present in this list to object type. We know that object type is the father of all the data types here. So what will it do? Since we have mixed string along with integer numbers here, it has converted all the data which is present in the list called data to object type. The second way by which we can create a series is by using a dictionary. So A is the key, 10 is the data or value. Okay, again B is the key, 20 is the value. If I make a series using a dictionary, my dear students, the index value is taken as the key value of the dictionary here. And the data type is in64. Don't get confused here. This 10, 20, 30, that is the values of the dictionary are taken as the series value here. That's why the data type is being shown as in64. The third way is by using a numpy array. We have already seen a numpy array, so we have taken a numpy array here and we can just pass it as a parameter of series function and it will create a series. Thank you, my dear students.